We have learned about speed, what speed is, and what is the difference between speed and velocity. You know what you mean by distance, what you mean by displacement, and also time. So those are some of the terms that we use to describe motion of a body. So let's look at this box here. So this gentleman here, my soldier here, is going to push this, and then we can able to see how we are going to relate that with our lesson today, which is about understanding acceleration. So right now we can actually see the box is not moving, so the speed is 0. So if we start, we give some push, then now you can able to see it is now moving from 0, and the speed you can able to see here, the speed is now increasing. So if I pause right there, initially the speed was 0, but now speed is at, if there is a unit, if this represents a unit, that there's 1, 2, 3, 4, 5, 6. So there's maybe 6 meters per second now. So the speed is 6 meters per second. If we continue, you can able to see it is now from 6 to maybe at this particular point, if we stop the stopwatch at that particular point, now it is a different speed, which has actually increased. So when the speed is increasing, we can confidently say that the body is accelerating. The other question is, what is acceleration? That is what we need to find out. What is acceleration? So that is our main question. And acceleration is defined in terms of speed, sorry, in terms of velocity. Very, very important. Acceleration is defined in terms of velocity. So this is a formula, but if someone asks you to define what acceleration is, then this is, we can say this is the rate of change of velocity. Sometimes instead of saying the rate of change of velocity, then we can just say that increasing, so the rate of increasing velocity. So the rate of increasing velocity. So those terms, so we define acceleration in terms of velocity. Why? Because there's a topic we're going to cover, which is called scalars and vectors. We'll be able to learn that acceleration is a vector quantity, and therefore is going to be defined in terms of a vector quantity. And why is it a vector quantity? It's because of its definition. So definition is in terms of velocity, and velocity is a vector quantity. So please do not define acceleration in terms of speed. Try as much as possible to avoid, because speed is just magnitude of velocity. But since acceleration also has direction, we need to give it that part to be that. So we will define acceleration in terms of change in velocity over the time taken. And if we look at all this, why are we having all this? So let's look into it. So change in velocity means that we're talking about the final velocity minus initial velocity. So it depends on your timing. Like for example, what we just did, the demonstration, you realize that initially the timing was at 0, and then after some time it was at 6 meters per second. After some time it was somewhere here. So it depends on what you're timing. So we are saying that initially, maybe the time can be 0, or time can be at a very particular point. It depends on what you're investigating. And then this is over the time taken. So final velocity is given by letter V. So that is why here we have acceleration A being given as V minus U divided by time t. V minus U divided by time t. So, and that is all. So you just need to know that acceleration is in meters per second squared. Final velocity is meters per second. Initial velocity is meters per second. And time taken is in seconds. So what we need to understand is that what is the unit of acceleration? What is the unit of acceleration? Now that we know how to calculate acceleration so what is the unit of acceleration? So just to supplement what is on the screen, what you can able to see, acceleration is given by change in velocity. So I can just write delta V over delta T. So the unit of V, or speed or velocity, is given in meters per second. And the unit of time, that is in seconds. So meters per second is just meters over second. Meaning now we will have, so from here, we will have meters per second written as this, divided by seconds. So this will give us meters over second squared. And therefore, we will write as meters per second squared. So the unit of acceleration is given as meters per second squared and is defined as velocity change over time taken. I know there's something interesting. I have really insisted that whenever we define acceleration, we do so with regard to velocity. But most of the equations that you're going to see even in the example, we will realize that we will be given speed, not velocity most of the time. Then we'll be wondering, hey, what about what Molimudelo said? So remember, when you talk about velocity, the magnitude of velocity, if let's say the magnitude of velocity is 20 meters per second, remember that magnitude of velocity is called speed, is a speed. So most of the time, we will be given the magnitude of the velocity, which is called speed. All right, so I think it's high time we look at some examples, if there's any calculation to look at. So a car sets off from a traffic light. It reaches a speed of 20 meters per second in 10 seconds. What is acceleration? The first thing to note, the first thing to note is that acceleration A is given by V minus U over T. So change in velocity over time taken. Just the way I had just mentioned, we have been given the magnitude of the velocity, which is speed. So if it sets off, it means that initially, the initial velocity is 0 meters per second. The final velocity is 21 meters per second. So therefore, if we substitute our values here, and therefore T is also there, T. So therefore, if you substitute where there is V, I put 21 minus U, which is 0, over that which is 10. This will give me 21 over 10, and that is 2.1 meters per second squared. So that is how we work out that. There's another example next. So just need to clear that. We move to the next. Okay. So the other one, calculate the acceleration of a car that changes in velocity from 5 meters per second to 25 meters per second in 4 seconds. So number one thing, acceleration is given by V minus U over T. So V is 25, U is 5, so that is 25 minus 5, that will be 20, time is 4, so that is 20 divided by 4 will give us acceleration to be 5 meters per second squared. The next example, calculate the final velocity of a train that accelerates at 0.3 meters per second squared for 60 seconds from initial velocity of 5 meters per second. I just want to explain, what you can able to see on your screen. So right now, we need to calculate the final velocity. So A is given by V minus U over T. For us, we need to make V the subject of the formula. So we'll multiply both sides by T. So we get AT is equal to V minus U. That is where we are here. So if we want V, we take U the other side and it will be a plus. So therefore, V will be U plus AT. U plus AT. So if you confirm, initial velocity is 5, and then AT, so that is 0.3 times 60. Confirm if this will give you 23 meters per second. So that is Again, that is how that is done. So there's another example here. You can pause and then you see if you have any question. Oh, no, I think we need to work to look at it together. This question is asking us the deceleration of a car that slows down from 18 meters per second to rest. So what is deceleration? Deceleration if acceleration means increasing in velocity, that means deceleration means the slowing down. So when a body slows down, that means it is decelerating. But then, interestingly, deceleration can also mean the negative of acceleration. So this question can be done in two ways. So the first way is what you can able to see on the screen. So if it is slowing down to rest, that means V is 0. So V is 0, we can able to see. So V is 0, so 0 minus U, that is 0 minus 18 divided by 3, that will give us acceleration, which is negative 6 meters per second squared. So remember, this is not deceleration, this is acceleration. When acceleration is negative, it means there is deceleration. But for us to find the deceleration, we know very well that deceleration is negative of acceleration. So negative of negative 6 will give us positive 6 meters per second squared. Maybe to avoid all those stories, this is what you do. If you want to find deceleration, just take initial. So just take 18 minus the initial value, the final value, I mean, over 3, and this will give you the answer directly, 6.0 meters per second squared. So if you want to find deceleration, I'm giving another formula here. I don't want to get confused though. So to find deceleration, just take U minus V over T. But remember, if you're looking for deceleration and you say it is V minus U over T, you will get a negative value. That negative value is acceleration. And therefore, to find deceleration, you need to do that. So I hope that is clear. If it is not clear, if you have any question, feel free to ask there. You will confirm those tables. I'm going to give you the answers for this table here, but you confirm with your answers and then you see if these answers are correct. If you have any question, put in the comment there so that we can able to respond as soon as possible. Here's a summary. So now, that is the end of understanding acceleration. I want to take you through the past paper questions, what they really ask in the examination part. So here is question number 1. A rocket is launched vertically upwards from the ground. The rocket travels with uniform acceleration from rest. After 8.0 seconds, the speed of the rocket is 120 meters per second. Calculate the acceleration. So we know clearly that acceleration is V minus U divided by time t. V is the final speed. So the final speed is 120, initial speed initially. So the launch from the ground. So from ground initially, it is 0. So we have 120 meters per second minus 0 meters per second divided by the time, which is 8 meters per second. So that will give us 120 divided by 8, and I'm getting 15. So the acceleration will be 15 meters per second squared. Sorry. All right. Number 2, a rocket is launched vertically upwards from the ground. The rocket travels from, did I just repeat? Okay, I think there's a repetition. There is a question number 3, which is part B of another past paper question. So let's look at it. This figure shows a skier taking part in a speed competition. The winner of the competition has the highest average speed over the 100-meter section that is shown on the diagram. The skier starts from rest. There is wonderful. This tells that U is 0. The moment you see that, has a constant acceleration. Wonderful. He reaches a speed of 60 meters per second in 16 seconds. So calculate the acceleration. So starting from rest, Never forget to write the formula. So A is V minus U over T. You can now be just singing this. So that is 60 meters per second minus 0 divided by time, which is 16. So that will give us, so 60 minus 0 is 60. So that is 60 divided by 16. That gives us 3.75. 3.75. If I want my answer into two significant figure, that will be 3.8 meter per second squared. Good. Help me confirm my calculations, just in case I make any mistake. I battery provide energy into electric car. So the electric car has acceleration of 2.9 meters per second squared when it moves from rest. The combined mass of the car and its driver is 1,600 kilogram. Remember, some of these are just selected part of what we need for this question. So we're not going to use mass anywhere because we know that acceleration up to what we know is that this is V minus U over T. But just in case you are wondering why are we having mass there, there's a formula which you're going to learn later on about resultant force. Resultant force when we need to know how force affects the motion of any particular body. So here we have been given acceleration, which is 2.9. V is 28. Initially, it was moving from rest, so minus 0. Over time taken, we are looking for time taken. So from here, we will have 2.9 is equal to 28 over t. I want to give you a trick instead of making another show. If you have a question like this, you want t, just do this. Take this t to where 2.9 is, take 2.9 to where this one is, meaning t is going to be 28 over 2.9. So that will give us 9.7 seconds. If you don't like shortcuts from what I've just shown you, if you have 2.9 is equal to 28 over t, what you do, multiply both sides by t. So this will cancel this. Then we'll have 2.9t, which is equal to 28. Divide both sides by 2.9. Divide those by 2.9, you see, you will cancel, and therefore t will take you to where we have here, and the answer will be 9.7. So I believe that now you understand how to work out, you need to know the definition of acceleration. We define acceleration in terms of velocity. We know that now deceleration means slowing down, which is a negative of acceleration. And we now know how to use the formula that is before you. So until then, see you in our next lesson. Bye.